right, so yesterday we talked about logarithmic expressions and equations. Today we're going to think about a logarithm as a function. And it happens to be the inverse function of an exponential function. All right, so there are actually quite a bit of restrictions on logarithms. So the base of a logarithm has to be greater than 0, so no negative bases. And the base also can't be 1. And then this number in front can't be 0. So that you just have to think about that. The base can't be negative and can't be 1. All right, so we learned how to look at a table of values and tell if a function was exponential. So whenever a function was exponential, the input values were equally spaced. So they go up or down by the same value. Do you guys remember what would happen for the output values on exponential? Good. You multiply by the same thing each time. So the input values are equal length, and then the output values change multiplicatively, which we didn't really use that word. We said change proportionally. So what happens when you do the inverse of a function? What do you do?
Be divided by a set number.
Dividing is the inverse of multiplying. But whenever you have a function and you want to find its inverse, do you guys remember what you did?
Multiply by a fraction.
So let's say you have a table of values. It's okay. You have a table of values and you want to find the inverse of that table of values. What do? You just switch x and y. It's okay. You're thinking about inverse operations and you just didn't understand the question. I know you know this. When you find an inverse, you switch x and y. So if you have an exponential function where the input is equally spaced and the output is changing proportionally, and you switch the x and y, what is going to happen now? Which one is going to be equally spaced? The output. And then the input is going to change proportionally. So this function here was an exponential function. And all I did was, or all Brian Passwater did, was change the x and y's. So now the output is equally spaced and the input is changing proportionally. So that's what you look for when something is a logarithmic function. That's all right. You're going to get this. I have no doubt. Okay, so on example 1, we have 4 different functions, and we're going to determine if they are logarithmic, exponential, or neither. And we are going to give the reason why we chose that, even though it didn't ask us to. And you're going to also do that on your homework as well. All right, so what I do when I'm making these decisions is I look to see which one is equally spaced. So if we're looking at A, is the input or the output equally spaced? The input. So that means I can forget about logarithmic on this one. So it's either going to be exponential or neither. So for it to be exponential, the output needs to be multiplied by the same thing each time. Is that what's happening? Yes. Multiplying by 1/2. So this one is exponential. And we're not going to write a ton. We're probably going to write more than you want to, but that's okay. The reason is the input values are equally spaced. And the output values are changing proportionally. And then when we look at B, which is equally spaced? The output. So there's no way this one can be exponential. So it could be logarithmic or it could be neither. So for it to be logarithmic, these have to have something that's multiplied by each time. Oh no, sorry, I can't say words right. Are you multiplying by the same thing each time? You're multiplying by 3. So this one is logarithmic. And it's basically going to say the same thing that I wrote in green, except input and output are going to be switched. Bless you. All right, so I want you guys to try C and D on your own, please. All right, what do you guys think about C? Good. And the reason, I mean, there's lots of things you could say, but if neither one of the things are equally spaced, bless you, then we're really not going to be able to say anything. So I'm just going to say nothing is equally spaced. All right, what do you guys think about D? Logarithmic, good. And then it would be the same, exact same reason as B. So on the back, there is a reminder about some things about inverses that we learned about previously, like right before Christmas, actually. And some new stuff. So if f is b to the x, then g equals log base b of x are inverses. So they have the same base, the exponential, and then the logarithmic with that base is going to be its inverse. All right. And if you do the composition of inverses, everything should simplify away. It's a little dusty under there, but everything should simplify away to just x. Now, we haven't learned enough properties about logarithms to be able to do this algebraically, so we'll come back to that later. But what we can do also is find inverses or graph inverses on the coordinate plane. So inverses are reflections over the line y equals x. And so there we go. This is the line y equals x. And so if you can visualize reflecting the graph over that, that's what the inverse is going to look like. Also, if the point x sub 1, y sub 1 is on f, then you switch that, and y sub 1, x sub 1 is on the inverse of f. So I like to use that a lot to get a good graph for my inverse. Okay, so on example 2, we have a portion of the exponential function 2 to the x. So on exponential functions, they have horizontal asymptotes. All right, so let's see what happens when we reflect this and get the logarithmic function. All right, so I'm just going to take this point right here, which is 0, 1, and switch x and y. So 1, 0 is going to be on my inverse function. All right, we also have the point 1, 2 on the original graph f. So 2, 1 should be on the inverse. All right, and then 2, 4 is on f. So 4, 2 is on the inverse of f. Okay, so this was the exponential, has a horizontal asymptote. What type of asymptote do you think the logarithmic is going to have? Vertical, so it is going to look like that. So that's basically what logarithmic graphs look like. We're really close, and then we curve through. All right, so on example 3, we're going to use the graphs above to evaluate some logarithm base 2. So you have two options. You can go back to the original, which is probably the best option unless you just drew your inverse perfectly. You can go back to the original, and if it's log base 2 of 5, you want to know what x value makes the original graph equal to 5. So if you're going to estimate that, what would you say? Anybody have a guess? It's a decimal?
2 1/4.
Sure. Right. The other thing you could do is go to you graph log base 2 of x. So go to where x is 5 and find the y value there. And so at this point, I did halfway decent actually. It also looks like about 2 1/4, so that's not too bad. This is the one where I kind of messed up, I think. All right, so log base 2 of 1/3. So we go to the original. We want to know what x value makes that graph about 1/3. So here's about 1/3. And so it looks like about negative 1.5. When I did this morning, I used my inverse. And so when x is 1/3, I got something like negative 3, which is off. So if you're checking your answers with mine and they're way off, it might be that you just need to go back to the original, or you might have done it wrong. I'm not stressing out about these. They're just estimates. It's fine. All right, and then example 4 is a question about average rate of change. So we know that h is an exponential function, and we know 2 points that are on h. We want to find the average rate of change of y equals log base a of x. So what's the relationship between these two functions? They're inverses. So we could have called, instead of y equals, this is the inverse of h. Oh, sorry. So what 2 points do we know are on h inverse?
2, 3, 6, 27.
But 3,
3
2,
and 2.
yeah, and 27, 6. All right, average rate of change is a huge concept that we've done in every single unit. We've done it a lot. And so if I want to find the average rate of change of these 2 points, what would I do? What do I subtract on the top?
x1 minus x2.
Y is on top, x is on bottom. So we get 4 over 24, or an average rate of change of 1/6. All right, what questions do you guys have?